Welcome to this video where we'll explore how to migrate a MySQL database from Cloud SQL to Google Cloud Spanner. While Cloud SQL is an excellent starting point for standard database engines, Spanner offers unique advantages that make it worth considering for more advanced needs. Cloud Spanner is a remarkable database service that stands out for its ability to scale horizontally while maintaining strong consistency. It's particularly useful when you need to expand your application to a more global, internet scale level. Imagine you have an application currently running on Cloud SQL, specifically using the MySQL variant. Our goal is to smoothly transition this application from using the MySQL database to using Spanner. By doing this, we'll keep the strong consistency and relational database features we're using too, but we'll be upgrading to a more powerful Postgres-compatible service. Essentially, we're switching to a leading, modern, globally scalable database service. For this demonstration, we'll focus mainly on the database migration and setup, rather than making changes to the application itself. In a real-world scenario, your application would likely only need to be pointed to a different IP address once you've completed this kind of migration. Let's start by setting up our Cloud SQL instance. To keep costs low, we'll choose a lightweight database configuration. Since we're dealing with a traditional relational database management system, or RDBMS, we'll specify a single location for our instance. Let's use US Central 1 as our example. We'll also stick to a single zone to further minimize costs. Feel free to keep the other configurations at their default settings. While our MySQL database is being created, which will take a few minutes, let's take a look at the Cloud Spanner documentation to find the migration tool we'll be using. This open source tool is our key player in transferring databases. In our case, we'll be moving data from MySQL to Spanner. In the documentation, we'll focus on the MySQL specific examples. This will give us an idea of the types of flags and parameters we'll need to provide when using the command line tool. We'll need to specify details like the target profile, which requires having a Spanner instance already set up, as well as some source configurations. These can be specified either as command line arguments or environment variables. For our demonstration, we'll use command line arguments. To simplify things, we'll use the command line interface or CLI tool mentioned in the documentation, even though a user interface is also available. We'll be migrating both the schema, the structure of our database, and the data itself. While we wait for our MySQL database to finish creating, let's set up a small Spanner instance as well. We'll create a standard instance, and to keep things simple and cost-effective, we'll focus on a single region rather than a multi-regional setup. When setting up your Spanner instance, it's important to understand that the compute capacity you choose determines several key factors: throughput, maximum queries per second, and storage limits. This isn't like setting up traditional servers. Instead, think of it as a more abstract, managed experience where Google Cloud handles much of the underlying complexity for you. Now, let's create our Spanner instance. This setup should cost less than $1 per hour, making it perfect for our demonstration or for small-scale projects. With our Spanner instance set up, let's create a database within it. We'll call it Inventory, imagining it's some kind of inventory management system. Spanner is compatible with both PostgreSQL and Google's own SQL dialect, both of which closely follow the ANSI SQL standard. For now, we'll leave the schema blank because our migration tool will take care of creating it for us. While the tool can also create the database itself, it's often helpful to have a pre-named, pre-set up database to work with. Next, let's switch back to our Cloud SQL instance and create a database there too. We'll use the same name, Inventory, and stick with the default collation settings. Cloud SQL provides a handy tool called Cloud SQL Studio that we can use to connect to our database. Let's try connecting with a user other than root, just to demonstrate how that works. Now that we're connected, let's check if we have the necessary permissions to create tables in our database. We'll do this by running a simple SQL command to create a shipment table with some example fields and then load a few rows of data into it. This will give us some data to work with during our migration. Great! Our table has been created successfully. If we examine the shipment table, we should see our columns, indexes, and a few rows of sample data. This should be enough for us to proceed with our migration work. Now let's turn our attention back to the Spanner migration tool. We'll be using the Schema and Data command to migrate everything into one setup. When we run the tool on its own, it shows us the different commands available. Let's use one of the example commands as a template, as it includes most of the specifications we need for our MySQL database. For this demonstration, we're using an open network policy to connect to the database. In a production environment, you'd likely want a more constrained setup, but for now, this will work fine. Remember, clients will still need valid credentials to log in, so it's not a major security risk. We'll need to provide several pieces of information to the migration tool: the host, the port, the username, the MySQL database, the Spanner instance, and the Spanner database. Let's put all this information into our command. The tool will prompt us for the MySQL password when we run it, so we don't need to include that in the command itself. Before we run the command, let's double check that all our settings are correct in both the Cloud SQL and Spanner instances. Everything looks good, so let's proceed with running the migration tool. When we run the migration tool, it first asks for the MySQL password. After entering it, the tool uses our authenticated user to connect to the Spanner instance. As the process begins, we might see some messages about environment variables. Don't worry if you see a note about not being able to store session data without certain variables set. This shouldn't affect our migration. However, we do encounter an issue. The Spanner ID configuration is missing a project ID. This is likely to cause problems, so let's address it. Interestingly, while the project ID wasn't needed for the schema migration, it appears to be necessary for the data portion. Let's check the console to see what's happening with our migration. We can see that our Spanner database now has a shipment table with the correct schema, which is a good start. However, when we look at the data, we find that it's empty. This isn't what we expected, as we should see the data we added to our MySQL database. To troubleshoot, let's do a quick check on our Cloud SQL system to confirm that we actually have data in the shipments table. Indeed, we do see our sample data there. Looking at the report generated by the migration tool, we see that it believes there were 0 rows transferred. This gives us a clue about what might be going wrong. Upon closer inspection, we realize we made a small but significant mistake. We forgot to specify that we wanted to migrate both the schema and the data. We only ran the schema migration. Let's correct this and run the data migration separately. When we try to run the data migration, we encounter another error related to the project specification. Let's add the project ID to our command and try again. Even after adding the project ID, we're still getting an error. Let's do another sanity check to see if any data has been transferred. Unfortunately, we still don't see any data in our Spanner table. However, we do notice something interesting. The migration tool has created a metadata table about the migration itself. While this isn't the data we were hoping to see, it does indicate that the tool is doing something. At this point, it seems like we might be facing some issues due to the piecemeal approach we've taken. Let's try running everything together in one command, both the schema and data migration. This might help ensure that everything is properly coordinated. When we try this, we encounter a new problem. The tool doesn't like that we already have an existing schema in our Spanner database. We're close to success, but we need to clear the decks and start fresh. This will give us a clean slate to work from. Don't worry, we'll recreate the inventory database in Spanner before we run the migration again. With our databases recreated and everything reset, let's cross our fingers and try the migration one more time, using a single command to migrate both the schema and the data. This time, we get a more promising output. The tool reports that all 5 rows were successfully written to Spanner. However, it also mentions that only 71% of our 7 columns mapped cleanly. Let's take a closer look at the report file to see what might have gone wrong. In the report file, we find some warnings that explain the column mapping issue. There were 2 main points: a conversion of an auto-increment field for the ID column, and a notice about data type changes in Spanner. Specifically, Spanner converted the ID column to INT64, a 64-bit integer type. This change accounts for the less than perfect column mapping, but it's not a major problem. In fact, apart from this small issue with the ID field, everything else looks good. We achieved perfect results on the data transfer and very good results on the schema transfer. Now for the moment of truth. Let's check our Spanner database to see if the data is really there. When we open the table that was created, we can see all our data neatly arranged and ready to go. Success! We've successfully migrated our data from the MySQL instance in Cloud SQL to Cloud Spanner. This migration represents more than just moving data from one place to another. We've effectively upgraded to a more powerful and globally oriented database for our web application. Spanner offers enhanced scalability and performance that can support applications as they grow to serve users around the world. For those of you following along, we'll include the SQL code used to create our sample data, the final command we ran for the migration, and a diagram illustrating the migration process in the video description. If you'd like to support the channel, get a free trial of our new design tool using the link in the description and let us know what you think. Post any questions that you have in the comment section, and please enjoy responsibly.